In our last video, we went over 9 different properties of exponents. In this video, we're going to apply those properties to simplify different expressions that have exponents in them. We'll know when they are fully simplified by checking for 2 different rules. The first rule is that there cannot be any other properties applied to simplify and put different variables together. And the second rule is that we must end with only positive exponents. Let's take a look at our first example. Our first example is going to be x to the negative second times x to the negative third, all raised to the fourth power. First thing that we have is let's go ahead and simplify inside of here. We have x to the negative second times x to the negative third. Two things multiplied together will add our exponent. So we'll have x to the negative fifth, still raised to the fourth power. Now we have something raised to a power, so we multiply these powers together. And we'll have x to the negative 20th power. And finally, we will take this and turn it into a positive exponent by taking the reciprocal of x, so 1 over x, and then making the power positive. And this is it. This is as simplified as it gets. If you wanted to write this with an exponent on the outside, you could write this as 1 over x to the 20th. That's also fine. You can do that. I'm going to go ahead and leave it like this because we're going to have some other examples later on where the final answer needs to be written in a fraction form. Okay, our second example, n to the third times 2n to the negative 1. To simplify this expression out, we're going to first take care of this. We have something raised to a power. We can multiply those together. Get n to the ninth times 2n to the negative first. Next, we're going to take advantage of the commutative property of multiplication, where it does not matter what order we multiply things in. So I'm going to rewrite this as 2 times 9, or n to the ninth power, times n to the negative first power. Now we have these two things multiplied together. We need to add these exponents. So we'll have 2 times n to the 8th power. 9 plus 1 is 8. And 2n to the 8th is as simplified as this one gets. Our third example, oh gosh, this is a mess. 2x squared y to the fourth times 4x squared y to the fourth times 3x over 3x to the negative third y squared. Wow. Okay, so this is a lot to go through. Something to note is when we are simplifying out these expressions that have the exponents on them, there is a world where we can just write out all of the x's, write out all of the y's, write out all of the constants, all multiplied out together, and then just start canceling out. So what that would look like is we would have 2 times 4 times 3, then we have 1, 2, 3, 4, 5 powers on the x, so we need 1, 2, 3, 4, 5 x's, and we have 4, 8, and no more, so we need 1, 2, 3, 4, 5, 6, 7, 8 of our y's multiplied together, all divided by x to the negative third, or 3x to the negative third y squared. Let's write out this y squared. Will be 2 more y's. Since this is a negative 3, we're going to put them on the other side because we do a reciprocal. Then we have a 3 here. Next, we would do this 3 cancels out with this 3, this y cancels out with this y, cancels out with this y, and then we would push everything back together. We would have 2 times 4 times 1, 2, 3, 4, 5, 6, 7, 8 of those x's, and 1, 2, 3, 4, 5, 6 of those y's. So that would be 8. 2 times 4 is 8. X to the 8th, y to the 6th. That is explicitly everything that's happening in this simplification. But let's use some exponent properties to make this go faster. So let's redo this using our exponent properties. First, let's simplify this numerator. We're going to have all of our constants. 2 times 4 times 3 is 8 times 3 is 24. Then we have x to the second, x to the second, x to the first. That is 5 of those x's. Then we have our y's, y to the fourth, and none over here. That is y to the 8th over 3x to the negative third y squared. Now we would take 24, divide that by 3, and we get 8. We have x to the 5th divided by an x to the negative third. Remember, when we do division, we're going to subtract them. So 5 minus negative 3 would be 8. And then y to the 8th, y to the 2nd, we're going to subtract the 8 and the 2, and we get y to the 6th. And that was so much faster than writing everything out explicitly. So this is why we utilize those exponent properties and why we learn when we can add our exponents, when we can subtract them, because it makes the process so much faster. Let's take a look at a smaller one. We have x over 2x to the 0 to the second. Remember, anything to the 0 power is 1, so this is now 2 times 1, which is 2. 2 squared is 4. So this is now x over 4. And that is it. That is the simplified version of this expression here. That's all I've got for you today. If you found this video to be helpful, consider liking and subscribing, and if you have a topic you want me to cover in the future, leave it down in the comments below. As always, have a fantastic day.